Now we're going to go ahead and work some more absolute values from 1.8. And now we're going to talk about inequalities. Now when we talk about inequalities with absolute values, we're going to have to graph them. But we only have to check 1 point. We don't have to check 3 like we did before. We only have to check 1. And so for inequalities, for inequality absolute values, you have 2 possible answers. And the 2 possible answers are like this, where it's true, false, and true. And we shade the outer edges again. Or the other possible solution is where it's true in the middle. So on these, all we have to check is 1 point to see if it's true or if it's false. And normally we try and pick 0 because 0 is about the easiest number to check. So we'll do a few of these and then we'll look at some special cases. And then we'll talk about what happens when an absolute value equals another absolute value. But let's go ahead now and focus on our inequalities. And we're going to solve and graph these. And let's start with the absolute value of 4 minus 3 plus 5 is greater than or equal to 10. Okay, so we're going to try and solve and graph this one. Now, the very first thing that we have to remember is to move that 5 over, because the absolute value must be all by itself or alone on the left. So just remember that. So the absolute value must be alone on the left. So we're going to go ahead first and move that 5 over. And now we have the absolute value of 4x minus 3 is greater than or equal to 5. And you might want to go ahead and put a box around this because this is what we're going to be checking our solutions in. So we'll check our solution in that one. Now we get our 2 equations just like we did before. So our 2 equations would be 4x minus 3 equals 5, or 4x minus 3 equals a minus 5. So we'll get our 2 equations and we'll solve them. So just add your 3 over, and that gives you 4x equals 8. Divide by your 4. And one of the numbers on the number line is now a 2. Repeat the process for the other one. So add your 3 over. And so 4x equals now a negative 2. Divide by your 4 and reduce. So the other one is going to be a negative 1/2. Okay, so we got our 2 equations. We solve them. Now, because this is an inequality, we have to put them on a number line and we have to check. So let's go ahead now and put our numbers on the number line. And we've got a minus 1/2 and a positive 2. And the easiest number to check, if possible, is going to be 0. And so where's 0 at? 0 is right here in the middle, because 0 is in between the minus 1/2 and the positive 2. You only have to check 1. So now we're going to check x equals 0, and we're going to check that in 4x minus 3 in the absolute values is greater than 5, so we'll plug in our 0. 4 times 0 is 0, and that's gone. What's the absolute value of a negative 3? Well, that's a positive 3. And is positive 3, is that bigger than 5? No. So that means that middle region is false. Now, the good thing about these is you don't have to check the other two. They always switch back and forth. So it's either true, false, true, or false, true, false. Well, ours is false in the middle, so that means these two regions must be true. We use square brackets because it's greater than or equal to. And how do we write our answer? We write our answer as negative infinity to negative 1/2 with the square bracket. We use a U for union, 2 to positive infinity. So that's going to be our final answer in interval notation. Let's try a couple more of these. Then we'll look at an absolute value equaling another absolute value and the special cases. So let's do one more of these. This is again going to be a solvent graph. Let's work with the absolute value of minus 3x plus 2. Inside of our absolute value bars is less than 8. That's what we're going to be working with. Now, we don't have to move anything over because the absolute value is already alone on the left. We get our two equations, which would be a minus 3x plus 2 equals 8, or a minus 3x plus 2 equals a negative 8. So we have a positive 8 for one equation and a negative 8 for the other. Now we just simply solve them. So move your 2 over. And we've got a minus 3x equals positive 6. Divide by a negative 3 and reduce. So one number that we're going to have to check is going to be a negative 2. Repeating the process, we subtract off of our 2 on the other equation. And so we get a minus 3x equals a minus 10. We'll divide by our negative 3. And that gives us x equals then 10 thirds. So not much to do on these. Put them on the number line in the correct order. We've got a minus 2 on the left. We've got a positive 10 thirds on the right. And it looks again like our 0 is going to be right in the middle. And so now we'll check that 0 in our original. So we're going to check x equals 0. And we'll check that in the absolute value of a minus 3x plus 2 is less than 8. So plugging in that 0. Three times 0 is 0, so that piece is gone. Absolute value of 2 is 2. And is 2 now smaller than 8? Is 2 smaller than 8? Yes, 2 is smaller than 8. So that would make that then true. So that means this region in the middle is true. If the region in the middle is true, then the edges are going to be false. Our original was strictly less than, so we use parentheses here. And what does my answer now look like in interval notation? Well, in interval notation, it looks like parentheses -2 10/3 with a parentheses as well. Is everyone okay with how I did that? So pretty simple on that one. Now let's look at some special cases. And the special cases are a little bit different because the special cases are going to either have no solution or an infinite number of solutions. So these are going to be our special cases. And these are special cases when the right-hand side is negative. So this is an example of a special case. And why would this be a special case? Well, it's going to be a special case because that 4 is negative. So that makes it a special case. Now, these special cases are either true or they are false. So let's think now about absolute values. When I take an absolute value of a number, what are my options? My answer.
I left the calculators, the extra scratch paper, and your student's scratch paper on the desk.
Okay.
And I will see you tomorrow.
All right. Hey, thank you, Melanie. Okay, so what we've got is we've got this absolute value. Now, what do we know about absolute values? Well, we know that absolute values always give you out either a positive number or 0. And what do we know about positive numbers or 0? Are they going to be bigger than a -4? Is that true or false? Positive numbers, are they bigger than a -4? Yes, positive numbers are always bigger than a -4. So that would make that then true. So my solution would be negative to positive infinity. We did not have to solve this one though. So when the right-hand side is negative, it's a much, much easier problem. And don't try to solve it because you'll end up with the wrong answer. If it's a special case, your right-hand side is negative, it's either everything or nothing. Let's do a few more of these. How about the absolute value of minus 5x minus 1 plus 10 is less than 7. Now, it doesn't look like a special case, and we're going to solve this one. But it is going to be a special case because before we do anything else, what must we do? We must make sure that the absolute value is by itself on the left. So we're going to move that 10 over. That's the first thing that we do. And then when we move that 10 over, now it becomes a special case. Because 7 minus 10 makes it that -3, and that makes it then a special case. Now, what do we know about absolute values again? Absolute values only give you out a positive number or 0. That's your only choice. And our positive numbers, are they going to be less than a -3? Are positive numbers smaller than -3? No. So that would make this one then what? That would make this one then false, and we have no solution. We'll probably do 2 more of these just to make sure we know how they work. What about an equals? Let's try and solve the absolute value of 3x minus 1 equals a negative 4. Now this one again, because of that negative, on the right-hand side, that's going to make that again another special case. And what do we know about absolute values? Well, absolute values are either positive or 0. And can a positive number, can that ever equal a negative 4? Can positive numbers ever equal negative 4? No, that is not possible. So then you have no solution again. And these are going to be either true, meaning everything, or false, meaning nothing. So let's work through one more of these. This one's going to be a little bit different. Let's say I give you the absolute value of 4f minus 7 is less than k, with k being less than 0. Now this one is a little bit different, but we're going to have to find a value for k that makes it work. So what do we know about k? What's the condition on k? The condition on k is that k is what? K is less than 0. So let's pick a number that's going to work. How about we use k equals a negative 1? And is negative 1, is that less than 0? Yes. You could have used negative 20, negative 3. It doesn't matter. As long as your k is less than 0, we're going to use a negative 1, which it is. And now what do we know again about this absolute value? Well, the absolute value is all alone on the left. The right-hand side is negative, so again, that makes it a special case. Absolute values are either going to be positive or 0. And our positive or 0 numbers, are those less than a negative 1? Is that true or false? Are positive numbers smaller than negative 1? No, they are not. So that would make this one again false. And so if it's false, we have no solution. And let's do one with 0 just to make sure we understand how 0 works as well. Let's say it's greater than or equal to 0. And again, we're going to have to solve this one. Okay, 0 kind of makes it a special case again. So what do we know? We know that absolute values are either positive or 0. And our positive numbers, are they bigger than 0? Yes. So that would make that then again true. And if it's true, it's like an identity. So my solution set would then be negative to positive infinity. So that's how you work out and solve those. Now, what about an absolute value equaling another absolute value? Well, on these, we're going to get, again, 2 equations, but we're going to have to distribute a negative sign through. So let's try and solve absolute value of 4x minus 3 equals the absolute value of x plus 9. Now, this is an equal sign, so we're not going to have to graph this one out. We only have to graph the inequalities. How do we handle an absolute value equaling another absolute value? It's just like the equals we have done before. So we need to get our two equations and solve them out. We do have to be careful with a negative because we're going to have to distribute that negative through. So what do our two equations look like? They look like 4x minus 3 equals x plus 9. And all I did was I dropped the bars. And that's one equation. What's the other one going to be? 4x minus 3 equals a negative, use your negative out in front, parentheses, x plus 9. So what you're going to do is you're going to have to make the left-hand side negative and distribute it through. So here's our two equations. We got one where we drop the bars, and then we got the other one where we have to distribute a negative on the right. Go ahead and distribute that negative through. And we'll solve the left-hand side first, or the left-hand equation first. So we'll move that x over. We'll add the 3. And that gives us then 3x equals 12. Divide by your 3. And x now equals 4. Same process on the other side. We distribute our negative through. So that makes it 4x minus 3 equals, distributing your negative through, minus x minus 9. We'll add the x over, and we'll add the 3 over as well. That gives you then 5x on the left and a negative 6 on the right. Divide by our 5. And our solution is then minus 6 fifths. So we have our two answers for this absolute value. We've got 4 and we've got minus 6 fifths. But what's the key takeaway here? When we work with the right-hand side, we have to distribute that negative through. Let's work through a couple more of these. And we're going to solve this one out. How about 3x plus 7 in the absolute value bars equals the absolute value of 2x minus 1. Okay, so this is what we've got here. Now, what are my two equations going to look like? Well, the first one, we drop our bars. And when we drop our absolute value bars, what do we get? We get 3x plus 7 equals 2x minus 1. What about the other side? Well, the other one is going to be 3x plus 7 equals a negative parentheses 2x minus 1. And on that second one, remember we're going to have to distribute that negative symbol through. So Let's focus now on the left-hand side. And so we'll move that 7 over, and we'll move that 2x over as well. And that leaves you then with x equaling a -8. The other one is going to be 3x plus 7 equals now a -2x. And watch your signs. Negative and negative makes it a +1. So we distributed that negative through. That changed our signs. Now we're going to go ahead and add our 2x to each side. And we're going to subtract that 7 as well. So 3 and 2 makes it a 5x. The 7's cancel. The 2x's cancel. And 1 minus 7 makes it a -6. We'll divide by our 5. And that gives us now x equals a -6/5. Let's look at another one here. This one we're going to get several solutions to. And this one we're going to have to factor. And this is like question number 1 in your homework. So let's look at one like question number 1 about the absolute value of x squared plus 81 equals the absolute value of 18x. This is what we've got to work with. Now, we are going to have to factor twice. So what are our two equations going to look like? Well, they're going to look like x squared plus 81 equals 18x. Our other one is x squared plus 81 equals a -18x. But these are going to factor out nicely. These are both perfect square trinomials. So let's go ahead and factor and set each one of these to 0. Because remember, again, these are nonlinear. But they'll factor out nicely. So move that 18x over. Make sure they're written in the correct order. So that's x squared minus 18x plus 81 equals 0. What two numbers multiply together to give you 81? Add together to give you a -18 in the middle. Well, I'll give you a hint. 81 is a perfect square of what? 9, right? Okay, 9 times 9 is 81. The sign in the middle is negative. So we'll use a -9 and a -9 because -9 minus 9 is a -18. And the double negative when you multiply makes it that positive 81. So that factors then into x minus 9, x minus 9, and these are the same. So we only have to solve one of them. So x minus 9 equals 0. That gives you, when you move it over, your first solution, which is x equals 9. What about the other one? Same process. Add your 18x over. That leaves you now with x squared plus 18x plus 81 equals 0. And again, 81 is a perfect square of 9 and 9. The sign in the middle is positive. So we use a positive 9 and another positive 9. That factors into x plus 9, x plus 9, and x plus 9 equals 0. Well, that gives you x equals a negative 9, doesn't it? Before we move on to the practice exam, let's talk quickly about question 15 in your homework. This is a question that students ask about a lot. It's an application, but it's all set up for you. So what we're looking at on question 15 is we're looking at a palm tree. And depending upon the conditions, the palm tree is either going to have a larger trunk that year or a smaller one. They give you this inequality. And they want to find the range. So the average annual growth rate of palmetto palms in inches satisfies this inequality. What is the range of growth that corresponds to this inequality? Now, it sounds like there's a lot to this, but all we need to really do on this one is solve this inequality. That's it. What's our answer going to be in? It's going to be in an interval, and our units of measure are going to be in inches. So for question 15, I'm not going to work it out for you completely, but for question 15 in your homework, all you need to do is solve this inequality. So all you have to do is solve the absolute value of x minus 3.47 is less than or equal to 2.75. And then your answer is going to be in inches. So the answer has inches as the units. And I think you can finish it from there. That one is one though that students always struggle with because they think you have to do a lot more to it. But that one is already set up. So you'll solve it as an absolute value inequality. You'll get your answer. And when you have your answer, make sure you label it with inches on the end. And it's going to give you a range of values. Because again, depending upon the conditions that year, if you get more rain or not enough rain, then the palm tree is going to be bigger or smaller, how much it grows. So for question 15, you just need to finish that out. Let's go ahead now and take a short break again, and then we'll come back and we'll spend the balance of our class time working on that practice exam. So let's meet back here at about 8:25. So try to meet back here at about 8:25.